Welcome to the IM2 video lecture. This is covering solving a quadratic equation by graphing. Here are the learned targets for you to understand how to solve using the graphing method. There are 3 success criteria that you should be able to do by the end of the video. 1. You should be able to graph a related function based on a quadratic equation. 2. You should be able to find and locate the x-intercepts of a graph. And 3. You can determine the solution/roots based on the x-intercepts of a graph. Okay. The way we want to go about this is you want to make sure you go to desmos.com. You should locate the graphing calculator right here. Click on it. This is the graphing tool that you're going to be using to do this. All right, so I want to recall the property of the discriminant. Based on 3 things, you could determine the amount of solutions available for your quadratic equation. If the discriminant here is positive, you could see that there are 2 solutions based on the 2 x-intercepts. If it's 0 for the discriminant, it has only 1 real solution. And if it is negative, it has no real solution, so no intercepts at all. Okay, this tells you how many they are. Today, we're going to learn what exactly they are. All right, so here we're going to do this exploration. Again, we're going to start by just using the diamond method of factoring. Okay, subtract 3 to both sides. Okay, you get that. Then you could try the diamond method of factoring because your a is equal to 1, b was equal to 2, c equals to -3. Okay, you plug that in. The 2 numbers that multiply to get -3 are 3 times -1. And the 2 numbers that add is 3 plus -1. So your factors are 3 and -1. In factored form, it would be x plus 3, x minus 1 are your factors. If you find a solution, just set those equal to 0 and solve. So x equals to -3 is one of the solution, and x equals to 1 is the other solution. All right, so now this is the diamond method of factoring. We're going to do the other way, which is graphing. So step 1 or step 0 is to always put in standard form, which was subtracting the 3 over like before. Here, next, you graph the related function. So rather than have it equal to 0, it equals to y. So you have y equal x squared plus 2x minus 3. Okay, you go to Desmos right here, and you type in the function for it. Okay, so you have y equals, if you don't know it, the calculator function, the calculator function is also here if you need to learn how to type it. All right, it is x to the power 2 plus 2x minus 3. Notice now I can click on the 2 locations for the x-intercepts. Okay, it is the points where the function crosses the x-axis. So I have a picture of it up here. I should now find the x-intercepts. The x-intercept is when x is equal to -3, as well as when x equals to 1. The solutions or the roots are the x-intercepts of this graph. So you could automatically say x equals to -3 is the solution, and x equals to 1 is also the solution. There you go. Very straightforward. Next, let's do this problem. Well, this is the problem from before. This is the core concept. From here, I just wanted to make sure you can see that both methods will get you the same solution. Okay, you can pick whichever one you prefer. All right, so this is the core concept. If you would like to take notes on it, remember, you could always, if you want to get the factors, you can always go backwards. So what you can do here is you can add 3 to both sides. Then you get x plus 3 equals to 0. That's why that's the first factor. Here, subtract 1 to both sides. You get x minus 1 equals to 0. X minus 1 is your second factor. All right, let's look at this problem. We're going to solve this by graphing. And this is when you're going to see when it has 1 solution. So add 16 to both sides. So -16 plus 16 gets you 0. On the left hand side, you get x squared minus 8x plus 16. Do not do this. I've seen students do negative 8x plus 16 becomes 8x. This doesn't work, folks. You can't do that. Okay, there's no x on the 16. So now you want to graph the related function. Y equals to x squared minus 8x plus 16. The related function is basically setting it equal to y. Okay, that's how it looks like if you put in Desmos. You want the solutions or the roots or the x-intercepts of the graph. That is when x is equal to 4. So x equals to 4 is your solution. If you want the factors, you subtract. You can go backwards. So subtract 4. You get x minus 4 equals to 0. So x minus 4 is also the factors, right? So x equals to 4 is your solution, though. This is when you have one solution. Next, this is when you're going to see when it has no solution. Again, put it into standard form. If you want to subtract the 2x and the minus and subtract 4 over, you can, but it's easier if you just add x squared to both sides. Okay, move one thing at a time. You get x squared plus 2x plus 4 equals to 0. Graph the related function, which is y equals to x squared plus 2x plus 4. That's how it should look like. Notice it does not cross the x-intercept, which is right here. Does not cross it. The solutions or the roots are the x-intercepts of the graph. Because this one has no x-intercepts, there are no real solutions. So there you go. I showed you an example of graphing it when you have no solutions. This is an example where you have one solution, and the core concept is when you had two solutions. But the methods are basically the same. There you go. That is everything that you need to understand when it comes to solving a quadratic equation with the method of graphing.